When I introduced to you Newton's method, we were looking at this function over here, y is equal to x cubed minus 2x plus 1. And we mainly used it to figure out, okay, what is Newton's method saying? How does it work? What does it look like? But we actually never approximated this negative root. And that's what I want to do in this video. So why don't you pause the video and try to use Newton's method to approximate this negative root of this function here. And I'll let you know, I'm going to use x is equal to -2 as my initial guess. So if you want to use that one as well, go ahead. Pause the video. All right, assuming that you've given it a go, again, we want to apply Newton's method. So we are going to let our initial guess, let x naught be equal to -2. And then applying Newton's method, we have x sub 1 is going to be equal to, we have -2 minus f of -2 over f prime of -2. And now we need to find what f of -2 and f prime of -2 are. So maybe I'll rewrite these guys up here. We have f of x is equal to x cubed minus 2x plus 1. And then we have to take the derivative. So using some power rule here, we have 3x squared minus 2. Okay, so let's find f of -2 and f prime of -2. We get, this is -2 minus f of -2. Let's see. We have, that looks like -8. So we have -8, and then we have plus 4 plus 1 in our numerator. And then our derivative evaluated at -2. That is 12 minus 2, so that's 10. So we get the following. We have -2, and then this is -3, so minus -3/10, and this comes out to -20/10 plus 3/10 plus 3/10. So we have x sub 1. We have x sub 1 is going to be -17/10. Or we could say also -1.7. So what just happened here? I want to show that graphically. What just happened right here? Well, we said our initial guess was going to be x is equal to -2. And then Newton's method, remember, it just makes a tangent line for this function at this x value, and then it finds the x-intercept of that tangent line. So come down here, and it looks like we're going to run out of some graph. Extend down here. We actually found what f of -2 was, and that is -3. So it's going to be somewhere down here. Maybe we can put a point right there. And we said the x-intercept of this tangent line was -1.7. So right in there. So let's try to get a tangent line going. Let's see. Not perfect. Let's try it one more time. Right there. That's looking better. All right. So that's our tangent line. And again, this x-intercept here, this is, let me get back to my pen. There we go. This x-intercept here is x sub 1, and we can keep applying Newton's method. So let's do Newton's method again under this new x value. So let's apply Newton's method again. I'll go with orange. So applying Newton's method again, we are now going to do this. We have a -1.7 minus f of -1.7 over f prime of -1.7. And then plugging this in, I plugged it in on my calculator beforehand, and I found this. I found -1.623088456. Okay? And again, we want to keep applying Newton's method, so you can check these on your calculator, but I applied Newton's method 2 more times. So after doing Newton's method again, I found -1.618055004. And then once more, I found this. I found -1.618033989. Okay, so applying Newton's method a few times, and then I want to show you what my graphing calculator gave me. So my graphing calculator said that this root over here was negative 1.61803. And you can see after we've just applied Newton's method a few times just how good of an approximation Newton's method gives. So that is pretty cool, and we were able to approximate the root of this function. And again, remember, we didn't have tools to approximate any roots of this function, so it's pretty cool that we were able to approximate this root here. Now, before we go, I want to also bring up one more thing. Let's say that your initial guess, let's say maybe there's one of you out there that said, you know what, I don't want to try -2. I want to try my initial guess to be negative square root of 2/3. So pause the video and try Newton's method under this initial guess and see what you get. All right, assuming that you give it a go, again, just like what we did before, we're going to apply Newton's method, but with this initial guess. So negative square root of 2/3 minus f of negative square root of 2/3 over f prime of the negative square root of 2/3. So what do we get here? Well, I'm actually going to start with this derivative value first, and maybe you can figure out what I'm doing here. So our derivative, remember, is 3x squared minus 2. Plugging in negative square root of 2/3 for our derivative function, we get this. We have 3, and then when we square this, we are going to be left with 2/3 minus 2. The 3's will cancel, and we're left with 0. So this whole denominator here becomes 0. And you can see we have a 0 in the denominator. This is undefined. So what happened here? What happened? What's wrong with this initial guess? And if we come back up here graphically, you can see what happened. So right here is negative square root of 2/3, and that represents this maximum point. And if we were to make a tangent line here, we can see that when we make a tangent line at this critical point here, we have a horizontal tangent line. And remember, Newton's method is making tangent lines and finding the x-intercept. When we have a horizontal tangent line, it's never going to intercept the x-axis. So that is why Newton's method blew up. So you can see, like, oh man, Newton's method's great, but now there's something wrong with it. Yeah, we're going to talk about some weaknesses of Newton's method in the next video.